As the flagship institution and the only public research university, one of the prime goals is to advance economic development and partner in the future of Maine's workforce. And the relationship of the university with the Maine forest industry is a very strong one, and one that impacts a wide segment of the university, from engineering to forest resources and beyond. What's going on at the university? That might be new technology, new things, markets, what could be happening in the future. And we'll have some tours this afternoon of the nanocellulose activity as well as the structure center. But it quickly kind of focused in on this area of mass timber as an area where there's a lot of action going on globally, North America and the U.S., and has the potential to impact your businesses in a very short time frame, and that's one of the things we're going to be exploring. So the program, and I'm really happy that we were able to get these people. Ricky McLain from Woodworks will be starting us out. He's a UMaine alum and a structural engineer. Russell from the university. We have Matt from a construction company. Jeff Easterling from NELMA. Casey Malmquist, who's president of SmartLam, which is a CLT manufacturer based in Montana. I'm aware of 4 manufacturers in North America, 2 in the U.S., and so we have half of the U.S. People here today. So our first speaker, again, Ricky from Woodworks, Ricky McLain.
So mass timber, I'm going to give you a brief overview of what mass timber is, the products that go into it, and I think what you'll find is that a lot of the products here in Maine, specifically dimensional lumber, 2x framing lumber, that's really what makes up mass timber. Traditionally we think of heavy timber framing, such as an 8x8 solid wood column, a 10x14 solid wood beam. Mass timber has very similar size members to those heavy timber elements, but it's not a solid piece of wood. It's made up of a composite of many smaller pieces of wood that are nailed or laminated together with glue. And I like this graphic a lot. I think it really ties together what mass timber is. We traditionally think on the left here of what a post and beam structure is. That's, again, going back maybe 100 years ago, that would be that post and beam heavy timber structure, right? Well, in the past 100 years, that's all changed to structural steel, maybe some cast in place concrete. So we're very familiar with how that system works, but modern way, really not so much so with wood. Light frame, that's where we know wood works really well, right? 3, 5-story wood frame structures. We're talking about 2x4, 2x6 studs in the walls, I-joists, trusses for the floors and the roof. So that's really where most people think of wood working well, is that light frame structure. So what mass timber does is it really takes the best of both worlds. Now we're going back to the wood frame post and beam structure. As we'll see in a second, glue laminated timber, columns and beams, those are creating the post and beam frame. But mass timber can also be used as a bearing wall system, like we have with light frame. So we're actually, instead of beams and columns, we're supporting the building with walls. So we're able to use solid mass timber walls there too. So it's really combining the best of both worlds, and then there are many other benefits that I really won't have time to go into today, but I'll touch on a few of them as we go through. So as we start looking at putting a building together, putting a mass timber building together, this first is looking at the vertical framing system. So basically creating the skeleton of the building. So, I'm assuming these are probably beams here and these drop soffits. So what's actually holding up the floor or the roof above us? So the first thing, as I mentioned, glue-laminated timber, columns and beams. That's basically just forming the framework, the skeleton of the building. Another common way to do it with mass timber is mass timber walls. So bearing walls, these cross-laminated timber walls. And I'll get into in just a second exactly what I mean by cross-laminated timber, glue-lam beams and columns. But that's kind of forming the skeleton of the building. Once we have that skeleton, now we need horizontal surfaces, right? We need the floor system. We need the roof above us. So that's where we have a pretty big variety to choose from. Today I'm just going to be focusing on these top 3, but as you can see here, there's a number of other options as well. So we're going to focus just on nail-laminated timber, cross-laminated timber, and glue-laminated timber today. But first, going back to the skeleton, I mentioned glue-laminated timber, often used as a beam and column system. And really what glue-laminated timber is just simply taking 2x-dimensional lumber, so let's say a 2x6, and we're laying it flat. We're running a screen of adhesive on that, and we're laying another 2x6 on top. So you can see here, we're just stacking these up. So we can make that beam really as deep as we want. I've seen glulam beams that are 5 feet deep, and then the width is really just what we're starting with, a 2x6, a 2x8, 2x12. So it's a very simple makeup. As you can see here, it's using a very common product, right? Just a 2x6, a 2x8. And it's making a very, very sound structural system because of that. And a lot of times people think of glue-lams as being, maybe it's just like in a residential application, a 15-foot long beam. I just wanted to highlight too that glue-lams can do much more than that. Shapes, spans, really flexible. This is the Richmond Olympic Oval. This is in British Columbia. This was constructed as the speed skating rink for the 2010 Winter Olympics in British Columbia. The roof here that you see, those are glulam arches. There actually is a double glulam beam there. Each one is 5 feet deep, and they clear span 330 feet across the entire arena. So pretty significant on what you can accomplish with wood framing. Another example, I think this is a beautiful space. This is an auto museum in Washington State. And you can see these arches here. These are 3-hinge, 3-piece glulam arches. So you have the first piece going up. You can see that silver. See the connection here, and then another piece, and then the third piece of glulam arch. So that's a 104-foot clear span across there. So just another example of how glulam can really not only perform well in that skeleton structure, but also in these unusual shape buildings as well. So that's our skeleton. We have the beams and columns. Now we need the horizontal surfaces. So the first one we'll look at is nail-laminated timber. And what nail-laminated timber is actually very simple. It's something that was used in traditional post and beam structures 100 years ago or so. It's kind of died off since, but it's really starting to see a resurgence. And it is as simple as taking dimensional lumber, again going back to using common 2x6s, 2x8s, orienting them vertically now, just nailing one ply to the next. So literally just creating a solid timber panel of products that we can buy right off the shelf. So what you're looking at in this picture here is you're looking up at the underside of a floor. So this is a glue-laminated timber beam, and then this is the nail-laminated timber panel. So each of these is a 2x lamination that's formed into a solid timber panel. One of the main benefits that we see with mass timber is you're killing two birds with one stone. It's the structure, it's also the finish. And not only is it the finish, it's a beautiful finish. Right? You're not looking up at, sure, this looks okay, but imagine if this were a nail-laminated timber finish, right? The finish is so much better. We actually heard from folks that they're able to charge more for rent because of the beautiful exposed finish, such as mass timber here. An example of a project that used nail-laminated timber panels. This is the Bullitt Center, Seattle, Washington. This was completed in 2012. It's a 6-story building. The top 4 floors are framed with mass timber. The lower 2 floors are framed with concrete. And so they used nail-laminated timber panels here. You can see going across. And then the glulam beams and glulam columns like we talked about. You can see this is a photograph under construction. And what they found here, this is the finish condition. What they found here is that one of the other benefits of mass timber is you can see they're framing these with a column at each beam. So normally in a structural steel system, you would have a beam at the perimeter of the assembly here, and so that would reduce basically the daylight penetration into the building. What they found is by going to this nail-laminated timber panel system, their windows are literally from the floor to the ceiling. So they were able to get more window height, more daylight penetration, a warmer office environment. Second option that we're going to look at for mass timber horizontal surfaces is glue-laminated timber. And we looked at glue-laminated timber a while ago just as a beam or a column. This, essentially, you can think of this as making a deep glulam beam. Usually these are 2-foot wide panels or so. Just taking that glulam beam and laying it on its side and putting multiples of those beams next to each other to form a solid timber surface. And so there's a little bit of a difference structurally because normally a glulam beam, you would have the plies, the laminations at the top of the bottom of the beam, be different species, higher grade because that's where the structural forces are highest. It's not the case when you lay that on its side, but for simplicity's sake, you can just think of it as a glulam beam laid on its side. And then the last horizontal surface I was going to talk about today, and you'll hear about this quite a bit throughout the day, is cross-laminated timber. For anyone that's not familiar with what cross-laminated timber is, I've heard it described as plywood on steroids. It's essentially made up, again, of 2x lumber. You can see the common theme throughout the day. Mass timber is made up of usually 2x materials. 2x lumber. So what we do is we'll start by laying, let's say we're going to take 2x6s. We'll lay 2x6s side by side on their wide flat face. Then we'll run a screen of adhesive across that. We'll lay another layer of 2x's, but in the opposite direction. So now we're creating this cross lamination that you see here. And the face plies of the cross-laminated timber are going the same direction. So there's an odd number of plies. So we're talking about a 3-ply panel, a 5-ply panel. This is looking at the end grain. So what we have here is our face ply this way. The next layer is going the opposite direction. There's adhesive. There's an adhesive line here, etc. So we have a strong axis of the panel that goes along the length of the CLT. Dimensions, common dimensions, we're talking about a panel that's 4 inches up to 15 or 20 inches thick. This is solid timber. Panels are usually 8 or 10 feet wide, and then the lengths are oftentimes just capped by what you can ship. So 20, 40, 60-foot long panels are not uncommon. You start to think about we're placing one panel that's covering 400 square feet at a time. So construction speed and efficiency, you can really start to see some benefits there. This is an example of a project that used cross-laminated timber. This was completed at the end of last year. This is a 4-story hotel in Alabama, Candlewood Suites. This was done by a development firm called Lend-Lease, and they have done a number of these hotels as actually part of military housing projects. And they've always done these with cold form steel framing. And what they found is they kind of want to do this as a pilot project and to see if it made sense, and they found that it has, and they're going to be doing this more in the future. But what they found with this project is a lot of the construction efficiencies of erecting the building faster, of having less people on site. They found that this project required less than 50% or 50% less people on site than their cold form steel project had. And in the process of doing that, they still completed the project 25% sooner. So mass timber is a very lightweight system compared to structural steel or concrete. Lightweight structure means your foundations are smaller, seismic forces are smaller. It's very fast to erect, like we talked about. You know, you're laying 400 square feet at a time. It's funny, we were assisting a developer out on the Pacific Northwest, and he was looking at one of these photographs, not this project, but a similar photograph, somebody erecting a CLT panel. And he said, wait a second, what is that crane? He was just running the numbers in his head, saying that crane is smaller than I have to have on site for a precast concrete system. That savings alone is going to save me $700 an hour just by having a smaller crane. So the savings trickle out. Oftentimes when we're talking with folks about costs of mass timber, many folks just stop at what's the structure cost? What's the cost per square foot just of the structure? And a lot of times the mass timber will come in a little bit higher than a steel or concrete system. But what you have to do is kind of get below the surface and find all these other savings. You know, if your building can be constructed faster, you don't have a general contractor on site at $150,000, $200,000 a month, right? You have savings in, if the building's done sooner, your clients can get in the building sooner, you get rent sooner. As I mentioned, the foundation savings, the seismic savings. So there are many benefits of using mass timber, and one of the challenges that we see is overcoming that initial hurdle of just looking at the initial structure cost. Project a little closer to home here. This is in Amherst, Massachusetts, at the UMass campus there. This is their design building. This is under construction now. It's a 4-story mass timber project, glue-lam columns and beams, cross-laminated timber floor and roof. This is going to be housing quite a bit of they have a pretty strong wood technology program there. This is housing a lot of those classrooms and laboratory facilities. And this project has quite a few unique systems. Not only is it just the standard CLT wall, glue-lam column and beam, they have a lot of cantilevers that mass timber can accommodate fairly well. They're even using CLT like you see here. This is I don't remember if this is the elevator or stair shaft, but they're using solid wood wall panels for the shafts as well. So you can see how, I mean, they're erecting the entire shaft in one lift of CLT. That goes up very quickly compared to normal traditional construction materials. This is a project in Minneapolis, Minnesota, and this one for me was really an eye-opener. I was in Minneapolis back in March, and I had the opportunity to walk to the construction site here. They were just erecting the timber on the top floor here. And because of the size of the building, and I think, I had helped quite a bit on these mass timber projects, but never seen one of this scale in person. And I'd say, if you have the opportunity to go to a mass timber construction site, I definitely would recommend it. This is a 7-story building. It's 6 stories of mass timber on top of 1 story of concrete. Also, interesting fact on this project used over 1.5 million board feet of lumber. So very significant, as you can see, that direct impact to what you deal with every day. This is using same system, glue-lam column and beam, nail-laminated timber floor panels. Those are 2x8s. The 2x8 floor panels here, and those span about 20 feet, so column system every 20 feet. And that's what a rendering would look like of the interior once it's complete. This is almost done construction. The timber portion is done. And it was funny, I was talking to the architect on this project and on the UMass project as well. They were giving a tour of the UMass project, and one of the architects on the tour just went up to one of the exposed wood columns and just put their arms around it. Just gave it a big hug. And they were saying it was funny because you do that same tour on a concrete project, you're probably not going to find anybody hugging a concrete column. So just, the warmth, the invitation of an exposed mass timber structure does make a difference to the occupants. And then finally, I wanted to look ahead to kind of the upcoming market, the trending market of mass timber here in the U.S. And that is, we're starting to see a push for taller wood buildings. If you've been keeping track of headlines as it relates to mass timber at all, every couple of weeks you see architect proposes 80-story mass timber structure in London. Very tall mass timber buildings are being proposed, and they're not just proposals, they're actually taking place in North America and specifically here in the U.S. A couple of years ago, the Softwood Lumber Board, in conjunction with the U.S. Department of Agriculture, started the Tall Wood Building Prize competition. And what they were doing was looking for design teams to solicit tall wood projects to them as they wanted to encourage the increase of that type of building. And they had many good nominations. They ended up awarding prizes to 2 of them, one on the West Coast, one on the East Coast. Each project received $1.5 million to support funding, because those projects, these tall wood projects, don't prescriptively fit within the code now. So one of the projects on the West Coast in Portland, Oregon, these projects are both still under design. They haven't started construction. This project in Portland, Oregon is going to be 12 stories, 5 stories of residential, 5 stories of offices, plus some retail as well. And then the project on the East Coast, right in New York City, a 10-story structure. Both of these are exposed glue-laminated timber column and beam system with cross-laminated timber floor and roof panels. Internationally, we've seen even more attention to tall wood projects. This is kind of showing, it's funny, this graphic, if you start on the left here, I don't know if you can see it from the back, but in 2009, the tallest wood structure in the world was 8 stories in London. Now, fast forward to where we are now, the tallest wood building was just completed at 18 stories in Canada. The project on the far right, a 24-story structure, is proposed to go forward soon. So we're definitely seeing an increase in mass timber tall wood buildings. This is completed at the end of last year. This is in Norway, 14-story mass timber structure. And that, at the time it was completed, was the tallest wood building in the world. That's been surpassed by this project. This is the Brock Commons project. It's a student residence housing project, about 150,000 square feet in British Columbia, just north of Vancouver. And one of the things with this project, I talked a while ago about speed of construction, and this project really exemplifies that. 17 stories of mass timber completed in 9.5 weeks. About 2 stories per week completed. So it's just phenomenal to think about, how fast. One of the things with mass timber is that it's not the same as a normal construction site with wood, where the lumber supplier is delivering a stack of 2x. You're cutting each of those to length. You're installing each of those one by one. Mass timber is now a completely prefabricated structural framing system. So all of the floor panels you're seeing, all of the columns, everything comes to the site cut to length. There's a complete set of shop drawings done. Even in what order they're delivered, everything is laid out ahead of time so that truck number 1 comes, so you know exactly where to place those panels. There's a very small amount of on-site storage, which is helpful in city settings where there's not room for storage of materials. So everything is very fast and comes prefabricated to the site. I think I'm tight on time, so that's all I have.
The next speaker today is Russell Edgar, who is wood composites manager at the Structures and Composite Center here at the university. And we've been working with CLT about 3 years, but Russell will tell you more about that.
Great, thank you, Steve. Welcome everyone to the university. I had a longer presentation prepared, but we were very fortunate to get the folks from SmartLam out in Montana to join us today. So I'm going to cut my presentation by about 2/3 and give the time to these folks that can tell you some real-world stories. So please take the opportunity to meet them before you leave. This is the time to get to know what an actual manufacturer is doing, how we might collaborate, why Maine might be a good choice for a CLT manufacturing facility in the future. So I'll tell you who we are, some of the objectives that we have specifically related to CLT, 2 CLT projects I'll highlight just very briefly that we've been looking at over the last 2 years, and then talk a little bit about our capabilities. So the Advanced Structures and Composite Center, we've changed our name 3 times in the last 10 years, I believe. We are currently the Advanced Structures and Composite Center. We started out as the Advanced Engineered Wood Composite Center, really looking at glue-lam beams, reinforced glue-lam beams, that type of thing. But you'll see when you come over this afternoon that we've really expanded beyond just wood composites into other composites and hybrid composites where you're matching wood with fiberglass or carbon fiber, that type of thing. So our building's been around since the year 2000. We've had 4 major expansions since then, so we're up to 100,000 square feet at this point. And we've got, it's a very active facility. There's probably 35 of us full-time staff, 30 graduate students, and about 100 undergraduate students. So before I forget, you'll see on the tour this afternoon, we have a pilot line for making OSB, and some of you might notice that there's a major piece of equipment missing from our pilot line, which is a debarker. And it turns out with 100 undergraduate students, we do not need a debarker. So our objectives specifically are to become the leader in the region for everything related to CLT. Now, obviously, this is a collaborative effort with folks like Woodworks, with manufacturers, with investors, with architects, with developers, but we really want to lead the way here through the university to push this technology forward. And like Steve mentioned this morning, the second point here is there's lots of questions that need to be answered, and frankly, a lot of them are not R&D related. There's a lot of R&D that needs to be done, but frankly, CLT is already being produced. We could set up a CLT plant here tomorrow and start making CLT that meets the standard. So really, the first thing we want to get at are what are those questions that someone considering coming to Maine or a developer here in Maine would need answered to develop a plant in the state. So a lot of that is economics, things where we do have some expertise at the university. They're just not so much at the Composite Center, which is my role. Then what we'd like to do is put our facility to work to support this industry. And if a manufacturer were to come to Maine, I think they'll find that they've got, this will be a big benefit for them, having a facility like ours that can do the R&D, that can do the testing on very large scale. So we could test CLT lam stock, we could test CLT panels as large as they can make them, we could test entire CLT buildings within our laboratory. And then the last one, and not least importantly, although sometimes we forget, or at least I do, that we are here working at a university, students come first, but that's an important piece to it, that we're, these 100 undergraduate students that are here working on real projects in our laboratory are getting some very good experience. And a CLT facility isn't just about pumping out panels. There's engineers that are required, there's wood science aspects to it, there's a lot there behind the scenes. So just very quickly, there is a standard for CLT called PRG 320, and what you'll see here, let's see here, okay, so it's divided up into 2 categories. There's E-rated, and there's E1 through E4 here, and then there's V-rated, so V1 through V3. So E is mechanically stress rated, where you're mechanically stress rating every piece and determining the modulus of elasticity. The V-rated is just a visual grade, so number 2, for example. And down below, it'll show you here, each one's got a category. So V2 happens to be spruce, pine, fir, number 1, number 2 in the faces, number 3 in the core. So it's all divided up. And one thing that SmartLam just did actually was come up with a new grade, which is V4. So it turns out that the SPF in this category, in the standard, is spruce, pine, fir from Canada, not from the United States. So spruce, pine, fir south, which is what we produce here south of the border, now has its own category and grade as V4. That was just done within the last couple of months, isn't that right? Yeah. So that's great. They've done the legwork there, but that would be the same category likely that we would be doing here in Maine as well with our spruce and fir resource. Okay, let's talk a little bit about what we're up to here at the university. So one thing we started about 2.5 years ago was looking at a hybrid CLT panel. So you put spruce, pine, fir in the faces, you put laminated strand lumber in the core. So laminated strand lumber, for those of you that aren't familiar, is produced at only 2 facilities in the world. One of them's in Ontario, the other one's right here in Maine, up in Holton, which is in the Pacific, converted their mill back in 2007, I believe it was, from OSB to LSL, and I think they still run both products there, so they can go back and forth. But if you think about it, their press, they're producing material at times 3.5 inches thick, 8 feet wide by 64 feet long. That's one piece of wood coming off of the press. I can't think of a more massive timber product than that in the entire world, basically. I don't know if there's any other more massive timber than that. So what we started wondering was, is there advantages to using the engineered composite, which has much lower variability, more predictable design, some higher properties, especially in shear, for example. So we'll go into this in a second, but that's one of them. The second one is we've got a project where we're working with Woodworks on blast resistant for these Army type housings, for example. So this is a picture, not of CLT, but for years we've been looking at reinforcing wood with fiberglass. Here's one that we blew up in Florida. So there's a standard building made out of plywood and I-joists, and here's one that was reinforced with fiberglass. These are fun tests to go to if anything's interesting. Some of these pieces of plywood we found up in pine trees about 1/2 mile away. This is a picture of the CLT panel being tested in our laboratory, and we'll do a test this afternoon and actually break a panel in that same way. So let's get into this hybrid CLT. An interesting thing about CLT, especially if you're using 3 plies, so here's one using just SPF lumber, and what you see is often this panel will fail in rolling shear, or shear perpendicular to grain. So in the core, that panel has now failed, and here's a good view of it here where we used laminated strand lumber in the faces. But you get this rolling shear failure. And we were using digital. Shear's a funny thing. I'm not an engineer, but shear can be tricky to visualize at times, at least for me in my head. So we're using digital image correlation using stereo cameras, and we can actually track the stresses. We spray paint a pattern on this side of this beam, and we can see where these stresses are highest. So if you see these red areas, that's where these shear stresses are very high, and sure enough, it fails in rolling shear. Well, it turns out that laminated strand lumber has 4 or 5 times the shear capacity than a solid piece of lumber. So the idea was, what if we put laminated strand lumber in the core here, and now instead of failing in shear, this panel fails in tension, in bending. And we actually found that we got a 22% increase in the overall panel capacity. 22%, that's a big deal. So we published a paper recently that's here that was a presentation that was given at the World Conference on Timber Engineering in Austria a couple of months ago, and these results will be published in the Forest Products Journal in a couple of months as well. The blast-resistant CLT, this is another picture on the left of the CLT hotel that was built at Redstone Arsenal in Alabama, and what we're doing here is static testing, and then these producers, and SmartLam, I believe, is one of them, are going to be producing enough panels to build full-size buildings, and down in Florida next month, they're going to blow them up and use the data they got from the static testing that we did to as inputs to their model and see how well they can predict the performance during an actual blast scenario. So the manufacturing capabilities we have, again, I'll just quickly go through this because you're going to see it in a little while, but we do have a 4x8 press, which is nice, so we can make relatively large panels, 4x8. We have a smaller press where we can do 3 foot by 3 foot panels, and we also have a complete strand composite pilot line, so we can make OSB, we can make laminated strand lumber, that type of thing. And down at the bottom you'll see our original strong floor was, I think it was 30 feet wide, 30 by 90 roughly, which is fairly large, and we were testing 90-foot long glue-lams. Our expansion now has a 230-foot long strong floor, one of the biggest ones in the United States at this point, right here. So that's where I was getting at. Anything that you guys can produce, bring it on, and we'll figure out a way to break it. So our testing capabilities, we can look at mechanical properties, we can look at adhesive durability, that's a big one. We can look at creep, things like that. And there's just a few photos I'll go through here. That's a picture for those of you that can't make it this afternoon. That's our old strong floor, the smaller one, that's 90 feet long. These are the glue-lam beams that we tested years ago. I believe that those were nearly 60 feet long. There's a Norway spruce that we're going to hear about in a little while from Nelma being broken. So we do a lot of static bending tests. This happens to be an edgewise test. For CLT, you're doing flatwise bending. We have a tension tester, so that's important for determining the properties of the lam stock material. We can do short span shear. These are those shear tests that I was telling you about earlier. There's a uniform load testing that we'll show you. So we can do this in 3rd point, 4th point, or uniform loading scenarios. That's another picture of the short span shear testing. And we are an ISO accredited testing laboratory as well. So often the results that we put out in our lab can be submitted directly to ICC, the International Code Council, for example. So the conclusion really is that, when we had heard about CLT a few years ago, kind of wondering whether this is one of those technologies that might be a fad and come and go. And my impression after doing this for about 15 years or so that this isn't a fad, it's just going to take a little time to catch hold, and it's already catching hold. And it's really a train that's not going to stop moving. SmartLam's got a real head start on this. We've been building these for 4 or 5 years. They've been making CLT panels. You'll hear more about that later. But they have a real head start on working out all the bugs and getting that technology where it needs to be. So again, Maine, we hope to be a big player in this and support the industry any way we can here in the state, and answer the question whether Maine's the right place for a CLT manufacturer. So that's all I have. Thank you.
Now we're going to get into people that do this on the business side. So Matt Tonello is going to talk about their perspective and opportunities of CLT here in Maine and New England.
Hello, I'm a project executive with Consigli Construction in Portland. We're about a $800 million a year construction firm based, our home office is in Milford, Mass, but I've been running the Portland office for about 12 years now. And our office focuses on the northern New England market. We try not to go to Vermont too much. We like to stay in Maine. That's where our 100 or so folks are. We got field guys and carpenters, masons, laborers, and we are essentially just builders of the buildings you're in. We focus on the healthcare, academic market, laboratory, and commercial market primarily. I'm going to talk a little bit about CLT and mass timber opportunities. I went to UMaine. I was one of the hands-up UMaine grads. I also went to Boston University for an MBA, and I also went to UMass for a master's in structural engineering. And for the first 10 years or so, maybe 7 years, I worked in the structural engineering world, designing mostly structural steel buildings, concrete buildings. Once in a while, I'd get into a timber frame project, but very rarely. Did 1 or 2 glue-lam projects back then. And then I worked for Revit Technology, which was prior to Autodesk purchasing them. It was a 3D modeling firm, 3D modeling software that I was the structural engineering product manager for. Went into construction in 2002 and have been working with Consigli since. So Some of the products, you saw the first pictures of the glue-lam and the CLT and nail-laminated timber that we look at in these mass timber type buildings. And wanted to talk just first about what my motivations are to be here, to be part of this, to be talking about it. I have no real horse in the race here. We build whatever the design teams out there and clients want built for them. I think we do it pretty economically, and we help drive those projects to construction. And what we're typically looking for and hearing our clients want are environmentally responsible products. We're very interested in something that's safe and fast to build. I'm generally looking for less on-site labor. As you know, in the state of Maine, skilled labor is a real problem for us. If I had 10 people that knew how to swing a hammer and knew where to swing it tomorrow, I'd hire them. We really struggle in the high labor proportion trades like drywall trades, light framing trades, anything that takes 10 to 15 people to put on site in any one specific trade at any one time in this Maine market. We're having the same type of issues in Massachusetts, a lack of skilled labor. We're always looking for positive thermal and acoustic performance. I'm less attentive to that, but that's typically something that's being asked for by our clients. Aesthetically pleasing, something with uniform or known capacities and strengths. All of these sound like things that are wood products. Now we're getting into available subcontractor market that's able to construct it. We have very few timber framers in this market. We have a lot of really small companies that will do barns and timber restoration, but we're always looking for a timber framer that's got CNC capabilities, that can fabricate connections in the shop and know how to put them together with skilled people in the field. We're always looking for products that are readily available. And if I go back to the known subcontractor market, structural steel market is much more predictable for us in this market. We know I could buy a structural steel building frame, fabricated and installed from 10 to 15 different contractors in the Northeast market with a snap of a finger, and it wouldn't be a problem to find others to replace those if I had problems with them on site, if they had financial issues or labor issues. Always looking for readily available material. Steel, there's a lot of fabricators around here. Concrete I can buy from numerous concrete plants. I can't buy CLT anywhere, in the Northeast at least. Can't buy glue lams. I think there's a couple manufacturers, maybe one or two up in New York. Always looking for places to reduce risk as construction managers, always looking for ways to predict the finish date of a project sooner, be able to predict when material is going to be on site and predict how fast it's going to go up. Also, cost competitive materials. It's very hard to convince a client that they're going to spend a single dollar more on their structure. Usually something they don't even know that they have or they're buying. You're standing on it, you don't see it half the time. In here you don't see a single piece of structure, so you don't really care what it's made of. And we're also looking, and the design teams are always looking for predictable code paths, some way that they know they can get a project approved through the legislative, the administrative bodies, the code officials. These first 6 on that previous page, all easily dealt with by wood. And I would say that I could make a pretty good argument that they're equal or better than steel or concrete in any one of these ways. The limitations that we see: available field installers, like I mentioned, local fabricators. There's a perceived fire durability issue, but I think that that's being dismissed pretty well with studies and even referred to in the codes as being an easy thing to deal with. It's a little bit less flexible in longer spans. We're not seeing the timber, the mass timber, glue lams, CLTs, nail-laminated products being cost competitive in this market for low-rise stick frame construction. It's that market is very, very tough to beat in terms of cost. You can find independent contractors all the time to come in and work, for a lot less than what you would typically assume you'd be paying a skilled tradesman for. It does become a problem if the buildings become larger and you need 10 to 20 framers at once. Framing a building with a small crew, letting it go for a longer period than a construction manager normally would want to, is the way you can really get these small wood frame buildings constructed inexpensively. And actually, it's a market we don't even try and penetrate ourselves at Consigli. We focus a lot more on the commercial markets. Lobbying of the steel and concrete industry, I've heard about this as being a major issue for the wood industry. I don't know much about it. I just wanted to get everything up here that I could think of that was limitations. And then building code constraints, specifically on height. I'll touch on that a little bit more in a minute. And then these are the hurdles that I just mentioned that I think are pretty easy to jump over. If we got some more people in the market making, manufacturing, delivering this kind of product to us as builders and educating the design teams on how you could design efficiently and get it more pushed into the market. The harder hurdles, the really non-competitiveness of it, in the really the light stick frame market, the lobbying, and the building code. One of the interesting elements of a way you can really add value to a lot of clients that are looking for environmental stewardship, there's a program out there called LEED that rates the environmental performance of buildings through the design, and they have a criteria for locally sourced material being harvested and manufactured within 500 miles of the location that you're going to be building it. I did two circles, and you can see the green one is around Boston, Massachusetts, really a center hub for an enormous amount of construction in the Northeast, and then one around New York. The New York one almost gets up into Maine, but definitely the one in Massachusetts and Boston reaches all the way up to, looks up to the LP plant. So I got interested in this a couple years ago when I was trying to push a CLT structure on an apartment building complex in downtown Portland. Got a lot of pushback from some of the design teams that it was going to be a 7 or 8 story building, and I could see that a CLT bearing wall exterior structure could really, with a plank deck of CLT, could be cost competitive and also could be much faster to build than a structural steel building. And I ended up getting a lot of pushback from the design teams not wanting to take the stretch and trying something that may not meet exactly the code limitations. So I started looking at it then, had a couple presentations with a few CLT manufacturers, and got a little bit further. And I've started to look at where the CLT and glue-laminated products could work better or more competitively. And I started looking at the higher ed market and did a small case study recently with a structural engineer where we had them design 3 different structural schemes, one in structural steel and concrete, one in glue-laminated timber and a plank floor system, and one in glue-laminated timber, columns and beams, and cross-laminated timber floor plates. I'm going to breeze through some of the basic details, but this was the base structural system. You can see it's a structural steel frame. It's a concrete deck on metal, concrete floor on metal deck with a steel beam under it. That was the base case. This was the alternative 2 cases. We looked at the glue-lam timbers over on the left with the CLT up on the right here as the plank floor. And then we also looked at a laminated strand lumber product for the floors. At the same time, we did a parallel study on the exterior wall system, which is traditionally around here framed with light gauge metal and dense glass, a gypsum-based product with fiberglass face. Essentially the 2 pieces of the wall that are shown in red with the red arrows. Looked at exchanging those 2 materials for a solid laminated strand lumber or CLT wall system. I won't get into how we did it, but we ended up getting 2 subcontractor prices, and we used historical costs on the structural steel system. We do a lot of these. We know what they cost. We know what we pay per ton for steel. And then we looked at the cross-laminated timber and glue-lam option, and we got some proposals from a number of CLT manufacturers, one from SmartLam, one from Nordique up in Quebec, and a number of others across the world, actually. So this is the number of vendors that participated in some way or some form in this analysis. And I went over the top on the wood side because we had very little historical data on who would supply, what predictability I would get out of the vendor, whether I could get the material on time, whether it met codes. So we had a number of firms propose and give us very nice proposals. You're not supposed to be able to read this. It's just a lot of number crunching and data. We did go through a number of matrices of matching up different products. And we also looked at the environmental performance. We used Woodworks' environmental calculator and also the Athena software, and got some very, very positive results. Won't bore you with those details either, but it did play very well on this case study for a higher ed client who's building an environmental laboratory, and it's really an element that they really cared about. The current combination that worked was the best combination was a Douglas fir product for the glue-lams, or a spruce from Austria, believe it or not. The floor plates being the cross-laminated timber, either the spruce from Montana or the spruce from Austria came into the same approximate dollars. And then the exterior solid walls, we looked at SIPs, and which I didn't talk about yet, but I'll skip. And then we looked at the laminated strand lumber. The results, what we found out, it's a lot harder for me to source wood products of this large scale in this marketplace. I had to go far and wide, and not everybody does CLT and glue-lam, and not everybody does the type of CLT a client wants to see, and not everybody is as easy to work with on the pricing and predictability side as I usually get out of the structural steel fabricators and installers that we've got locally here. Now here's something Ricky mentioned earlier about looking at the total cost premium that some people get too focused on, I think. We looked at the two structural systems and compared the wood option with glue-lam timbers and the CLT floors. The best matchup I could make ended up giving me a 24% cost premium on the structure alone. So that's what I'm looking for. I'm looking for little anomalies all the way through our estimates. What's costing me more? What's the premium I'm paying for these different products? We looked at another scenario though when we saw that we were using some wood on the outside of the building, and we started using that for the lateral system, the stuff that holds the building in place when an earthquake or wind blows. And if we were able to use some of the CLT product on the outside of the building that's going to be a solid wall anyway, we were able to get the cost premium down to 6% on the structure. But then if you really look at it, which is what the client cares about, they don't care about all our details, 1,000 lines of data. They care about what the premium is on the bottom line. And if we look at that, it was a 0.7% premium on an $11 million building. The problem with that is that's easy to sell to a client and get them to make that decision if you're under budget. But if you're slightly over budget anywhere, it's very hard to get someone to pay even $1 more for something. It's like going to the deli and getting a turkey sandwich. You get $5 in your pocket, you see a store brand turkey sandwich for $5, but they tell you you can get the farm raised, better tasting stuff for $5.25. If you only get $5, you're not even interested in the stuff that's going to cost you slightly more. And that's really what the situation was here, is they got unfocused on the fact that it was a 0.7% increase. But we haven't stopped talking about it yet, because we're going into a VE scenario where we're trying to take some cost out of the rest of the job. They are still considering it. This was the baseline numbers. Can I have 2 more minutes? I got to tell you what the numbers are. So the steel and concrete system was about $775,000, and then these were the best 2 combinations. The conclusions: wood can be competitive with the right design team, the right client, and the right building type. It's a limited slice of the construction market right now, in that it doesn't compete well with the stick framing, at least from where I can see, and I can't go a certain number of stories, 5 or 6 stories depending on the type of building. The shipping costs, interesting, were not as big of a driver as I thought they would be. Looking at the Austrian and the German fabricators, they were not paying more than about 12 to 15% of the total value of the product to ship it here. Same thing for the Western US vendors. However, if you could slice out of that market that 10 or 15% and get it locally for less, it could become even more viable. Without a local vendor or a larger market from which to buy, it's more risk for me as a CM. I get very nervous when I only have one person I can buy from in an entire market, or one person I can rely on. That vendor goes down or the product falls off a truck, it's very hard to find the replacement. It's also very hard to find a good competitive marketplace for the clients who we work with to say that they want to work with. And then code limitations, this is that stories, the height, I think Ricky could probably talk about code limitations limitations of height of mass timber a lot better than I can, but this is where I really see the mass timber industry could really compete well is over 5 or 6 stories, because anything you're building with 5 stories with stick frame, it's almost impossible to get a sufficient labor force on site at once to frame that building and just rely on all the wood studs in the building to carry you. So if we could prefabricate it, lower the on-site labor cost, push it into some taller markets, and with some more flexible layouts in space planning, I think it would be a huge, huge market. And I would love personally to see it as a product that we can source from here in Maine. So, thank you.
Our next speaker is Jeff Easterling, who's president of NELMA.
So I'll just briefly talk about what we are, because many of you guys may not know. Started in 1933. We're one of 7 lumber rules writing agencies in Canada and the US. And we're primarily involved, obviously, in the Northeastern and Upper Midwest. You see here by the numbers, we have 50 mills in our system that we provide quality control services to. We're also involved heavily in what's called the heat treatment program. We have 460 facilities there, scattered across. These little dots here will show you who our customer base is. The squares are the sawmills. The circles are the heat treatment or wood packaging facilities. So what I want to talk about today is a project that we've been involved with since 2012, actually, when it was first brought up by our members, something called Norway spruce. And it is a European species. It was brought over to the U.S. for the first time in 1860. The first plantation was in Woods Hole, Massachusetts, brought over by immigrants. They were familiar with the species. They knew how it would grow there and hoped it grew as well here in the U.S. And so you had smaller plantations by landowners that were throughout the Northeast, actually. And then the biggest push for Norway came during the 1930s. The Civilian Conservation Corps planted millions of Norway seedlings. I mean millions. The Norway spruce here in the U.S. had never been tested for strength values. Sure, it had been tested in Europe. They've used it forever. But in order for it to be used as a construction species here in the U.S., it has to be tested for all of its design value properties. So architects, engineers will obviously know where they can use it, how they can use it, how strong it is, things like that. It's a beautiful tree, but as you'll see on the right, when you put it in a plantation, it's not necessarily that pretty, but it makes some incredible logs and subsequent lumber out of it too, we'll talk about. The one on the right is a plantation probably about 60, 70 years old. And it grows very well. It's fairly fast for our climate in terms of the rest of the spruce. It grows very straight. It's self-limbing in a plantation setting, so as a result you can get very clear lumber out of it. One of the first things we had to do was figure out exactly where all of it was growing. And this led to a lot of ground verification. We used the forest inventory analysis data, which is probably the best database for all species, but when it comes to minor species such as Norway was, We had to look and see if it truly was in some of these locations. So this kind of gives you an idea of where the volumes are according to forest inventory analysis. We found a lot more in other locations than what this was. You'll see the state of New York is the largest volume of the 2.03 billion board feet, and that's just in saw timber. So that's a large basket of wood that should be available to the industry to use as a log resource. So to begin the process, we had to come up with a sampling plan, because what's required to enter a species into the design value database, you have to make sure that you have not only the geographic representation, but you also have the volume. So you'll see the 7 circles here. These were our focus areas where we actually pull logs from to start the process. And I should say that this is the first new species in the U.S. to be tested structurally in 90 years. So I won't call it a once-in-a-lifetime event, but I don't know of too many other species out there that hasn't already been tested and been in production for years. So it's quite the milestone to get this particular species to market. So we took logs from these 7 areas that was approved by Forest Products Lab. And one of the very distinctive things with Norway, you cannot tell the difference, and I mean you cannot tell the difference between Norway spruce and the other eastern spruces, red and white, mainly here in Maine. When you get it in log or lumber form, you cannot tell the difference. So that was quite the challenge to make sure that we were actually testing Norway spruce and not white spruce or red spruce. So for each of these areas, we had to go into the woods, watch it being harvested, color coding all the logs. We ended up with three mills that produced all the lumber that we were looking for the test. But it was quite the challenge to go into, have individuals there to make sure, yes, it was a Norway spruce plantation. Yes, these logs are what we need. So it's a little unusual. It's quite unusual than any other type of design or testing program that we're involved with, and we test a lot of lumber. So we ended up with about 1,320 pieces that was tested. And it was tested here at the Composite Center, and hopefully, Russell, you'll show them some of that machinery that tested all those material. Our inspection staff had to go to each mill, and we needed select structural and number 2. Those are the 2 grades that you can derive all the other values for number 1, number 3, stud, all those particular grades. And this is a close-up picture of what I believe Russell showed earlier, but it was each piece had to be individually destructively tested, values obtained from that. Once all of the testing occurred, a lot of analysis that University of Maine did here. Everyone should be quite proud of the university here for just that project, because it was significant of obtaining that final value. Our goal was we wanted to test it in order to put it back into the spruce pine fir south grouping. So just a little bit about the project timeline. We talked about the sampling plan. We submitted that in March of 2015. And it was quite the process to 1 year later submit the final results in April or March of 2016, this year. And then there's lots of hoops you have to jump through, because all the analysis that was done, that the University of Maine did for us, had to be analyzed by the U.S. Forest Products Lab, because when you introduce a new species, they're going to look over it with a fine-tooth comb to make sure everything was tested properly, the right sizes were done, the right areas were where it grew, where it came from. So it's it's a process to go back and forth with American Lumber Standard and also the Forest Products Lab. But where we sit today, and it is almost a year since we started in October 21st, where the first test began. We will know by October 20th the final result of getting it put into that spruce pine fir south combination. And I'm 99.9% sure at this point that we will obtain that. And so that means Norway spruce can be milled at the manufacturers, and it makes it also a resource for CLT, because once it's in spruce pine fir south, it doesn't matter what species it is. So it fits right into our conversation today with an available resource, and it would be nice to use that to over 2 billion board feet of saw timber.
So I'd like to finish up the program, and again, this mass timber CLT is an example of a product that competes with steel and concrete as opposed to a wood product competing with another wood product, which we historically have been pretty good at doing. So that's one of the reasons there's a lot of interest in this area by the industry also. But I'd like to welcome Casey Malmquist, who's the president of SmartLam.
Good morning. Thank you all for being here, and I want to thank all those responsible for getting us here. It's been a really fun trip, short but sweet. I think Russell had a fair amount to do with that. We look forward to the opportunity to take a look at the industry here and potential location for a plant. We are actually in the process of expanding and are doing some site selection tours, so this kind of fit in nicely with this. Little history of me. I'm the president and founder of SmartLam. I am here with some of my associates, Robert, Allison, and John. When I got this thing started, my background, I'm a builder, developer, have been for 35 years. I also have a degree in environmental studies. And so the whole concept of CLT made a whole lot of sense to me. I think you'll see in the presentation there's some things similar to here, what you've seen, but also show you a little bit specifically about what we're doing in Montana. So on the environmental side, I've often wondered if we got the best scientists in the world put together and we could imagine and come up with the perfect building material, what would that be? I mean, clearly it would have to be structural. Obviously, there would have to be an aesthetic component to it. Environmental, which is becoming, increasingly important. And of course, it would have to be safe and meet all the requirements, intended for it. So what I find interesting is, I think if we worked real hard to invent something, we'd find out it's wood. I mean, it's small logs, and the beauty of it, you can grow it in your backyard. It's renewable, and that is a very distinguishing point about wood. So small logs in our world equate to big opportunities, and we'd like to show you how we think we can do that. We're located in the beautiful Flathead Valley of northwest Montana. We're at the gateway of Glacier Park. We're fortunate to live and work in a really beautiful part of the world. I have to say I love Maine. It's gorgeous here. You got a great state. We've got a 40,000-foot facility. We're on campus with a big wood distributor there in western Montana. So we're a small company trying to make a big difference, and mostly it's about our people, which I'm very proud of. So brief history of CLT, developed in Austria. Europeans have been using this for well over 25 years. As it came across the pond, with it came some standards for performance. Canadians adopted the European code, amended it. We adopted the Canadian code, amended it, and we're all operating under that, the ANSI APA PR 320. And then in the code, as was mentioned earlier, there are provisions in the code in 2015. They're pretty limited. There's an expansion of the code that will be introduced in 18 that they're presently working on, and hopefully we'll continue to get CLT and mass timber into more and more buildings. What is CLT? Again, plywood on steroids is the simplest way to explain it. Perpendicular layers run at a bias to one another. Just a real quick graphic. Our press, we can do 12 feet up to 41 feet and up to 9 layers deep. So the manufacturing of CLT, there's basically 13 essential components to it. In this process of creating this new equipment line, I had some people I was working with that were getting frustrated with our timeline. And one of them said, geez, Casey, you're just effing gluing 2-bys together. And it really isn't that simple after 5 years of doing this. Really, kind of the metaphor we came up with, it's a lot like making bread. With a cook, you can change a recipe, throw in a few things here, a dash of this, a dash of that, and you can come up with something that's pretty good. When you're baking bread, you got to follow the rules very carefully. It's got to be the perfect environment, the right ingredients, the right sequence, timing, and making CLT is very similar to that. So a pretty exacting process. So just running through our line real quick, really starts with QC. We went through several material providers to identify the ones that could get us the proper materials coming in. Moisture content is a huge part of it, obviously quality. And then we screen all the incoming material as it goes in. We bought an older line. Parts of it are older. We kind of integrated some old and new equipment. It's fairly manual. We're literally hand feeding in each of these boards as we start the process. So the first step is finger joining. We've got an old Graycon Dimpter finger joining line. We did some modifications to it and can do about 35,000 lineal feet a shift. Then goes through a planing process. In the process of making CLT, you have to plane the wood within 24 hours of actually gluing it up. We also need to get these boards as uniform as possible for lamination, particularly when you talk about cross-laminating, because we are going that perpendicular, which makes uniformity of the product really essential. We've got a stacking system that then it pre-cuts the elements to the length of the panel we're building and stacks them. We get a long stacker and a short stacker. We then move it with a large machine, the combi lift, into our presses. We use a single part PUR, non-toxic, formaldehyde free, expensive as heck. And then we put it in these big, these are clam shell style presses. We actually bought a very old press that came out of Italy. And then we quickly found it was kind of our constraint in production. And then we built the second one you see in the lower left-hand corner there. Again, these are 12 feet by 41 foot presses. We do multiple plies, so we can get 3 9-plies, 3 3-plies, 2 4-plies, 2 5-plies, and then a 7 and a 9-ply in this press. The glue trolley sits in between and we kind of seesaws back and forth between the 2 presses. So we always have one cooking and then loading the other. And then we've got a very large format CNC. This is a Hundager PBA. The track is about 120 feet long. We can get the one waiting, one finished, and one operating, so it's about 130 feet long track. It's a 4-head, 5-axis saw. That thing's a lot of fun. It's actually a little more, has more detail in it that we require. We've actually figured out ways to speed it up. We don't quite need the preciseness of that machine. And one thing we're proud of, we've got a zero waste facility, so every ounce of fiber that comes into the plant we utilize in some way. We're fortunate to be within a mile of the MDF plant. They take a large amount of our planer shavings and clean dust, and then we chip the balance of it. We've got a biomass heater that conditions our wood and heats our plant. So material properties of CLT, we went through some of this. I mean, most of you here are familiar with wood. One of the things I'm kind of interested in, the whole moisture management component of it, which is really unusual, particularly compared to concrete and steel. We're actually working with a company to design grain silos that are built entirely out of CLT because of the vapor diffusion, the moisture management properties. A lot of these listed here, quite frankly, some are pluses and minuses depending on, the application. Acoustics is a good example of that. For footfall, between building floors by itself, it's not that great, but which is why they make musical instruments out of wood. But we're looking at those as places of opportunity where we can create some proprietary and creative solutions to these. One of the questions that always comes up, no matter what we're presenting or how we're presenting, is the fire thing. And there is a lobby with the steel and concrete people kind of working against us, and that's the first thing they put up there is showing a building, typically a frame, stick frame building burning. But as we all know, if you're a camper and you try to start a fire, it's pretty hard to start a log with a bic. So I love the photo on the right where there's, two steel I-beams draped over a solid timber, and that's, after a cataclysmic fire event. So the charring effect, we can actually design into a building depending on its application to create that kind of a sacrificial layer, so knowing what that burn rate is. We're currently participating in some studies to get some more exact science behind the fire ratings on this product. So cultural benefits. I'm really into the environmental side of this thing, and I find some of these metrics pretty fascinating, and some of it I got from Woodworks, Ricky. Great place to learn about CLT is on the Woodworks side. But on the CO2 reduction, so the new plant that we have planned, that we're currently at 12 to 15 million board feet annual production. The new plant is scheduled for 48 million board feet. So between the stored carbon and greenhouse gas emissions avoided, that's over 100,000 tons of carbon that's either sequestered or emitted, which is equivalent to removing 20,000 cars from the highway for a year. I mean, that's pretty significant, and that's just one plant. Here you see the embodied energy graph. Again, timber compared to steel and concrete, or including plastic, are way out there. Timber is, particularly in light of global climate change, is an interesting solution. One of the things I find interesting is, the last 30 or 40 years, even from the federal government all the way through, there's been this big push to reduce greenhouse gas emissions through vehicles in the transportation sector. And they've been affected over the years to do this, but that really represents about 35% of greenhouse gas emissions. And buildings, the construction of them, the maintenance of them, represents a much larger portion of that. And so it's a real opportunity to make a difference in terms of what we can do with climate change. Sustainable, for those of you outside of the timber industry, that's another question we get is just, geez, that's a lot of wood. How are we going to do this? So how much time does it take to regenerate 48 million board feet of fiber in North American forests? So that gives you an idea of the sustainability. Renewable, this one is very, very compelling. Wood is the only renewable building material there is. What I find interesting is, we live in Northwest Montana, which has fundamentally been based in the timber industry. Even now, you go into a 5th grade class and ask any, 10, 11-year-old, is cutting down a tree a good thing or a bad thing? And even there, 90% of them can tell you it's a bad thing. So we do need to think differently about how we think about our forest management practices. Energy efficiency, this is another one we're studying. There's a lot of talk out there, much of it is anecdotal. Again, just like in pricing our product, when you look at the energy a picture of it. You need to look at it in a much broader context to, I think, really understand it. I mean, people, first thing they ask, what's the R value? And they'll get disappointed immediately when you tell them, but when you look at the entire system, which includes, you know, the conductivity, the thermal mass, lack of infiltration, and zero vapor transfer, that package as a whole actually competes very favorably on its own without any enhancements. And we're doing some studies on that this winter to help kind of prove that out. The economic side, it's interesting in the forest product industry, there's a very high metric to direct and indirect jobs. So again, on this 48 million board feet, that's 264 direct jobs, same amount of indirect jobs on that metric. So that kind of production can make a big influence on, you know, a community and an economy. So using CLT, one of the things we did is try to take a different look at this. You know, the focus has been on all these tall buildings, you know, 10-story, 12-story, 22-story, 44-story, 80-story. You can't build a business on building those buildings. What we tried to do is learn, first, how to make CLT. We got into the industrial matting market initially. It was just a very good way for us to produce a relatively simple product and learn how to make CLT. And discovered it's a very robust market, about $500 million annually in the US, driven a lot by the oil and gas industry. So we were making hay for the first few years of production. With the downturn in the oil prices, it was a pivot point for us. One that was planned was to move into the construction materials market. And even in those few short years, that market has picked up enormously. We've seen an exponential growth and interest in real projects. But we're also looking for different ways to use this. Rather than building a 22-story building, is finding one element in a building that we can do 22,000 times. Here's actually a building we just completed in Utah under construction. But here's an example of just a component to a building. This is an elevator shaft. We saw a picture of one of those earlier. You can also look at a stairwell system. But, you know, a typical CMU elevator shaft, which is very common, it drives the whole project. And the entire schedule of that project is driven on getting these elevator shafts up. So you're generally looking at over a month in construction time, you know, a dozen workers, several inspections every 8 feet. It's weather dependent. It can create a lot of constraints in your schedule. So a very simple solution to that is CLT product. And we've actually got several of these in use. This does depend on what code jurisdiction you're in. There is some ongoing testing on, you know, the fire rating of this element. It's interesting, they did a test in Canada with the FP Innovations, and they were looking for a 2-hour rating on a 5-ply, and they ended up getting in excess of 3.5 hours. So again, we're gonna prove out some of these metrics. This is actually a picture of one that we have installed quite closer. It's Quebec City. Yeah, so now we're, 1 to 2 day installation with the CLT panel. This project's been shown many times. I actually have the time lapse of it. This is the Redstone project in Alabama done by Lend-Lease. We're actually partnering with them on some things coming up here. Bill Tobin, who's the guy internally, is kind of pushing that with Lend-Lease. Again, all these challenges we're finding with workforce and numbers of people, and particularly projects that generate revenue. I think they cut 6 months off their schedule on this project. So those are real numbers. And again, what's interesting for us on the sales side, and it was covered in more than one presentation, is measuring the benefits of this. You have to do over a wide range of things, and it's very dependent on where you are in the country. Available workforce, weather conditions, pricing, transportation. I mean, there's just a lot of different metrics, and more times than not, we're finding that, again, when you look at the whole picture, it's a good solution to it. So, little different numbers than Ricky, but framing labor reduced by 43%, and real good energy performance numbers as well. So instead of 44 to 50 guys, 11 guys and a crane operator. And then to close, this is actually, I'm putting my money where my mouth is. This is my third CLT building I have on my property. And this is 7,000 square feet of constructed space for a horse barn. And we had the crane there for 5 days. And that's it.